Hello everyone, and welcome to a tutorial on how to make a wobbler. So this is a specific mathematical shape that rolls even though it is not a sphere or circular. It does involve circles. It's basically two circles that interlock together, and when pushed it rolls somewhat smoothly. It does have sort of a wobbling movement, which is why it's called a wobbler. But by roll, I really mean that the center of mass stays at the same height throughout its movement. This is going to be your project for the week, along with proving a small theorem about wobblers, chiefly why the circles have to be so far apart and intersecting in a certain way in order to make this work. So tune in to see what exactly you will be doing there. So you can make your wobbler out of any material you wish, so long as it is strong enough to hold its shape while also being able to be cut into or cut circles out of. So you might have some cardboard laying around. Cardboard works just fine. I have some chipboard here, which works great as well. So once you have your material, you're going to want to make two circles. You can make your wobbler any size you want. It doesn't really matter too much. I would say that different materials might lend themselves better to bigger ones or smaller ones, but you can experiment with this on your own. And to make these circles, you can either use a compass or you can just grab some kind of circular object and use it as a stencil. So I have this bowl here that I'm going to be using as a stencil to make my two circles. Okay, so we're going to go ahead and trace our two circles. I have this bowl here that I'm using. As long as you make sure that they are exactly the same, it really matters here. So I'm going to make sure I have a very nice outline. So you can see here we have one of our circles. We're going to place the other down here. And trace this. And there we go, we have our two circles drawn out. So now that we have our two circles drawn out, it is time to cut them out. So we want to be as careful as possible to cut them out as exact to the circle as possible. The more perfect you make these circles, the better your wobbler is going to turn out. And with that, let's get to cutting these out. Okay, so we have our two circles all cut out now, and the next step is figuring out how to cut the slot so that these two fit together in just the right way so that the whole body moves. Now the way to do this, you have to actually be pretty particular about it. You can't just cut two slots in and sort of hope for the best. This thing is actually pretty delicate. In particular, the centers of the circles have to be exactly r√2 apart. So the distance from this center to this center needs to be r√2, where r is the radius of one of these circles. What that means for us is that we need to cut a groove into this circle that is exactly, or as close as we can get it, to 29.2893% of the radius. But why r root 2? It seems like such a random number. Well, the reason why it's r root 2 is actually going to be the topic of your project this week. I will attach questions that lead you through a rough proof for why exactly these two circles need to be r root 2 apart, or rather the centers need to be r root 2 apart. You guys actually know enough to figure out the proof for yourselves. We have gone over things like trigonometry and similar triangles, which you're going to use to figure out this proof. Okay, so let's cut the grooves into these circles. Now, again, we have to be pretty particular with this. What we end up doing is measuring the radius and then measuring how far in we need to make the groove. Now, one problem we run into is where exactly are we measuring the radius from? Where exactly is the center of the circle? Now, we could guess on this and just guess that it's around there or something, but we want it to be as mathematically precise as we can, and we can make use of an old theorem we know in order to find the exact center of the circle. The theorem I'm talking about is Thales Theorem. So as a short review, Thales Theorem says that if you have a circle, and you have the diameter of a circle, and you have a point on some arc that the diameter divides, then when you draw a triangle here, it is guaranteed that that triangle has a right angle. Now, this theorem can be reverse engineered in that if you put a right angle up to the edge of a circle, let me get a right angle. If you put a right angle on the edge of the circle and have it touch two sides, those 2 points, if you connect them, you will get a diameter. So in order to find the center, we are going to find two diameters of the circle using Thales theorem and see where they intersect. Now we have a point where both diameters cross, and that point, by definition, is the center of the circle, meaning that any of these lines here is a possible radius that we could cut along. So I'm going to go ahead and do this to the other circle. Okay, so now we have our two circles, and we have drawn radii. We've found the center, so these are radii. Now we just need to figure out how far in we need to cut in order for these to slot together in just the right way. To do that, all we need to do is measure the radius. I'm going to do so in centimeters. And then we're going to multiply by our percentage. It looks like our radius is about 8 centimeters. Okay, so if our radius is 8 centimeters and our magic percentage is 29.2893%, what we're going to do is take our calculator and multiply our radius times 0.2893. And that gives us that we need to cut in about 2 1/3 centimeters. So let's take our ruler again and measure that out as exactly as we can. Okay, so now we have our circles. They're all cut out and they both have a groove in them. So it is time for the moment of truth. Do they slot together? Do they roll? Do they roll well? So with that, here goes nothing. You kind of have to force it sometimes. Or even make the groove bigger. That looks pretty good. You want to make sure that this looks as close as a 90-degree angle as possible and that they won't slide around very much. All right. Ooh. It's looking promising. Okay, so this is our creation. Let's go test it out. Oh. I can't even put it down, it just rolls off the table. So I think this is going to be good. Harry.
That's totally cool.
Yeah. It worked pretty well.
That was super
For
well.
attempt number one.
Attempt number one.
I mean, it is guided by a fan, but it was rolling pretty decently on its
It's
own.
got its own thing. Yeah, I don't think it takes much air at all.
Oh. Yeah. Nice.
That's pretty nice. Cool.
We did it. Thank you for watching this tutorial on how to make a wobbler. These things are really fun to roll around and play with and experiment with. Try and build them with different things. The idea to do this project came from this lovely book, Things to Make and Do in the Fourth Dimension. This is a book by Matt Parker. It has tons of projects that are super fun to do that involve mathematics.